Welcome to today's lesson. We are going to deal with multiplication of small positive integers. Multiplication of two numbers means adding the number repeatedly. So when you are told to multiply in some way, you're simply being asked to add the given number repeatedly. For instance, if we are having 4 multiplied by 2. 4 multiplied by 2 simply means that we are having 2 being repeated 4 times. So it simply means the 2 is repeated 4 times, which implies that if I have 2 plus 2 plus 2 plus 2 is the same as 4 multiplied by 2. So when you're having repetition of a given number in the given number of times that you are given, so it simply means we are multiplying the given number. So if you have 4 times 2, it is the same as 2 plus 2 plus 2 plus 2, which is equal to 8. So in multiplying the numbers, there are various methods in which we can apply in order to multiply the given numbers. So we are going to look at the mental strategies that are used in multiplying the numbers. So the first strategy we have is simply finding the product of two numbers, by simply multiplying or using the multiplication tables that we have. So we are finding the product using our multiplication table. It simply means we need a memory. We need to have the memory of our multiplication tables. So for instance, when we have a number 8 multiplied by 2, from our multiplication table, when we have 8 times 2, we simply get 16. We can go ahead and get another number maybe 9 times 3. 9 times 3 from the multiplication table, we are having 9 times 3 should give us 27. Then another numbers that are there on the multiplication table, we could be having 11 times 7, and 11 times 7 is simply 77. So this is one strategy in which we can use mentally to multiply the numbers, whereby you're using your memory for the multiplication tables that we have. Another way of multiplying numbers, the second way in which strategy that is used in multiplication of numbers is the use of the commutative law. Commutative law simply implies that if I have two numbers, A times B, then A times B is simply the same as B times A. It doesn't matter the order in which you're going to use in your multiplication. Whether you start with the first one or the second one, the answer will still be the same. So that is what is referred to as the commutative law. For instance, if I'm having 9 times 6, it's simply the same as 6 times 9. And 6 times 9 and 9 times 6, the two calculation will simply give us the same answer, which is 54. If I have another number, maybe 8 times 5. 8 times 5 is simply the same as 5 multiplied by 8. And 8 times 5 and 5 times 8 will just give us the same answer, which is 40. If I have a number, maybe 10 multiplied by 7. 10 multiplied by 7 is simply the same as 7 multiplied by 10, and that gives us 70. So we say that you are using the commutative law. You don't have any specific order in which you are going to use in multiplication. Whichever figure you start with, it will still give you the same answer. The third way of multiplying, or the third strategy that is used in multiplication of numbers, we have the associative law. With the associative law, it implies that if I have 3 numbers that I'm multiplying, let's say A times B times C, then A times B, if I start with the first pair, that is A times B, then I multiply later on times C, it will just be the same as multiplying the second pair first, that is B times C, then the answer obtained, you multiply it by A. So with associative law, it doesn't matter which pair of the multiplication you are going to start with. You can start with either of the pair, either at the start of the first pair, or you can start with the last 2 digits that you have in your multiplication. So the order of the pair of multiplication does not matter. You can start from either way. So A times B multiplied by C will be the same as A multiplied by the B times C. So an example could be, if I'm having such like figures, 2 times 5 times 7. It's just the same as 2 times 5 times 7. In this case, I'm multiplying 2 times 5 first, which will give me 2 times 5, I'll get 10, then multiply by 7. 10 times 7, it gives me 70. Alternatively, if I start from the other side, such that I have 5 times 7, which will give me 35. So I have 35 multiplied by 2. 35 times 2 will simply give me 70. So you find that whichever pair you start with, it doesn't matter. It will simply give you the same values that you have. So that law is known as the associative law, where the pair you are starting with does not matter. So those are the 3 mental strategies that are used. We've talked about the use of memory from our multiplication tables, then use of the commutative law, and use of the associative law. With commutative and associative law, there are some cases whereby they can be combined. You can combine both the commutative and the associative law. In that, you can alter the order of arrangement. So when you alter the order of arrangement, then you can come up with a number that is easier for carrying out the multiplication process. For instance, if I'm having a number like 55 times 20, I can split the number into 5, 55 times 20 is simply the same as 5 times 11 times 2 times 10. Then we rearrange, we make an adjustment, we alter the arrangement of the numbers as they are. So we can alter this arrangement such that we will have 5 multiplied by 2, then times 11 times 10. Then 5 times 2 gives us 10 times 11 times 10. Then from here, we can apply the associative law, where we said the pair you start with doesn't matter. So we can start by multiplying the first pair, which is 10 times 11. 10 times 11 gives us 110. Then multiply by 10. So when we take 110 times 10, we simply get 1,100 as the required answer. Another example could be if I'm having 80 times 40, then we have to split the 80 times 40 so that this is we will have 8 times 10 times 4 times 10. So then we go ahead and rearrange such that we have 8 times 4. Then 8 times 4 is simply 32. Then the associative law, whichever order of multiplication doesn't matter. So we can multiply 10 times 10. 10 times 10 is simply 100. Then multiply by 32. When we multiply 32 by 100, we get 3,200 as the answer. Another example we have is 45 times 30. 45 times 30 simply means that times 30 is simply 3 times 15 times 3 times 10. So if we rearrange, we are having 3 times 3. So 3 times 3 is 9, then times 15 times 10. So 9 times 15, we are supposed to get 135, then multiplied by 10, and our answer is 1,350. So that is when we are combining the two laws that we've looked at, the commutative law and the associative law, whereby the order in which you're multiplying will not matter for the commutative law. And with the associative law, we are simply talking about the pair that you will start with will not matter. The result will be the same. So those are the various mental methods that are used in calculating of the in multiplication of small integers. So when you are multiplying mentally, those are the three methods that are associated with the multiplication of numbers. The other method that we have in multiplication of number So we are having the multiplication algorithm for multiplying by a single number. So the procedure is as follows. You first multiply the single number by each digit in the other number, starting from the right. So you are multiplying the single number by each digit in the other number, starting from the right. Then after that, if there is a number that has a higher place value after multiplication, it is carried, then added to the digits in the higher place value. This is what we mean by what we are talking about. So if, for instance, you have 46 multiplied by 7, so if we have 46 multiplied by 7, in multiplication algorithm, we've said you multiply the single digit by the digits in the other number. So starting from the right. So the number on the right hand side is 6. So we multiply the single digit we are having, which is 7. So we multiply 7 times 6. 7 times 6 is simply 42. We don't write the 42 because 4 is in the higher place value. We write 2 and carry 4. So we carry 4. Then multiply 4 times 7. 4 times 7 is simply 28. The 4 that was carried, we add on this 28 such that we get 32. So our answer, 46 multiplied by 7, is 322. Another example. So you are having 407 multiplied by 3. Starting from the right, you have 3 times 7. 3 times 7 is simply 21. So we write 1 and carry 2. 0 times 3 is 0. Then plus 2, we get 2. So we write 2 at this place. Then the other number to the far left is 4. So we have 4 times 3, which is 12. So we will write 12 at this point. So we get that when we have 407 multiplied by 3, our answer is 1221. Just one more example on the same. So we are having 129 times 2. So starting from the far right, we'll have 9 times 2, which is 18. 9, we write 8 and carry 1. Then we have the next digit is 2. So we have 2 times 2. But remember, we carried 1. So we have 2 times 2, then plus 1. We get 5. So we write 5. Then finally, the last digit we have is 1 times 2, which is simply 2. So 129 multiplied by 2 simply gives us 258 as our answer. So that is multiplication algorithm for a single digit, when we are multiplying by a single digit. When you multiply a number by itself, for instance, if I'm having A multiplied by A, then I've repeatedly multiplied the A, then the value I'm getting will be a square of A, which is A squared. So if I'm having any number repeatedly multiplying itself, for instance, I can have 4 multiplied by 4. 4 multiplied by 4 is 4 squared. 4 squared is simply 16. So we say 16 is a square of 4. Then if I have 5 multiplied by 5, it is 5 squared, which is 5 squared is simply 25. So that means 25 is a square of 5. If I have a number 9 multiplied by 9, then this is 9 squared. So 9 squared is simply 81. And so 81 is a square of 9. So when you are multiplying a number by itself, it gives you a square. Another way in which I can multiply, or we can multiply the numbers, is simply using the distributive law, then using distributive law by making multiples of 10, then adding or subtracting a digit. So what we do is this. You can be having a number that you are multiplying, but this number is not a multiple of 10. So you make it a multiple of 10, then after that, you subtract a given digit from that number so that you get back the original digit, or you add a digit on that to get the original digit. So if you are having such like a case, then it means this one is the same as A multiplied by B, minus A multiplied by C. That is the first option where you are subtracting a digit from that multiple of 10 that you've made. Or alternatively, you could be having A multiplied by B, but this B, you are supposed to add on a digit for you to get the original value. So if you are having B plus C, we are multiplying by A, the required calculation should be A multiplied by B, then plus A times C. So what do we mean by whatever we are writing on this board? This one can be illustrated easily using the following examples. If, for instance, I'm having 3 times 32. Then I can make this 32 to be a multiple of 10. The nearest multiple of 10 from 32 is simply 30. So from this 30, if I have 30, for me to get 32, then it means I have to add 2 on the 30. So this will mean I'll have 3 multiplied by it is the same as 3 multiplied by 30 plus 2. So if I go ahead and do the multiplication, then it means I have 3 times 30 plus 3 times 2. 3 times 30 is 90. 3 times 2 is 6. So 90 plus 6, we get 96. So that is destructive method, whereby I've made 32 to be a multiple of 10, and our multiple of 10 in this case is 30. Then to make it 32, it means the digit that is missing is 2. So I'll have 30 plus 2. Then we open up this bracket, in that 3 will multiply 30, then plus 3 times 2. So we get the answer is 96. If you're having 4 times 28, then the nearest multiple of 10 that I have is 30. So to get 28 from this 30, it means I'll have to subtract 2. So 28 is the same as 30 minus 2. 30 minus 2, we are multiplying by 4. So it means we multiply 4 by everything that is inside this bracket. We will have 4 multiplied by 30, then 4 multiplied by 2 minus 4 times 2. So 4 times 30 is 120. 4 times 2 is 8. And remember, we are subtracting. So we have 120 minus 8. 120 minus 8 will give us 112 as the answer. So another example, we have 6 times 18. 6 times 18, to make it a multiple of 10, we are having 20 as the nearest multiple of 10. So for me to get back 18 from this 20, it means I subtract 2. Then we open up the brackets. That will mean 6 multiplied by 20, then 6 multiplied by 2. So we are having 6 times 20, we are getting 120, minus 6 multiplied by 2, it is 12. So we have 120 minus 12. The answer is 108. So 6 multiplied by 18 is simply 108. So that is using the distributive method, where you are distributing your figures by making a multiple of 10, then you either add or subtract a digit from that figure that has been made. Another method in which we can multiply small digits So the other method is using the doubling and the halving rule, whereby you will double one of the digits, then half the other digit, and go ahead and multiply. For instance, if you are having the following. We have 5 times 7 times 4. In this case, we can decide to double 5, because if I double 5, I'll get a multiple of 10, or I'll get a power of 10, which is easy in multiplication. Then we can decide to have 4. So that if I have 4, then I'm getting 2. 2 will be easier to work with in multiplication. So what do? I've doubled 5. If we double 5, we are getting 10. Then 7 is not interfered, but we have halved 4. So halving 4 means we divide this 4 by 2. So we will get 2. When we are having this, using the associative law, we said whichever pair you start with doesn't matter. So if I start with 7 times 2, then we are getting 14, then multiplied by 10. 10 multiplied by 14 is simply 140 as the required answer. Or alternatively, you can decide to start with 10. If we start by 10 times 7, then 10 times 7 is 70, then multiplied by 2. 70 multiplied by 2 is 140. So whichever pair you start with, the answer will not be different. They should give you the same answer. If I have to multiply 5 times 18, then we are using the doubling and the halving rule. It means that you have to look at which digit is easier to double and which one is easier to halve. So in this case, it is easier to double 5 than halve 8. So we can double 5, then halve 8. So when 5 is doubled, we'll get 10. When, it is 18 and not 8. When 18 is halved, you'll get 9. So we are having 10 times 9. 10 times 9 is simply 90. So that is using the doubling and the halving rule. The other method is using factors to split a number. So when you can decide to use factors to split the numbers given. Like, for instance, we have 11 multiplied by 12. So we can use the factors of 12. Factors of 12, we are having 6 times 2. Then, using the associative law, we can decide to multiply. So 11 times 6 is simply 66. Then 66 multiplied by 2 gives us 132. So it can be difficult for us to multiply 11 by 2 if you are asked just mentally to give 11 times 12 and give the answer. It could be a bit difficult. But when you split into the factors, then apply the associative law, then it will be easier for us to give the required answer correctly. Then another example we have is, if I have 8 times 33, then the factors I have could be 8 multiplied by 3, 8 times 11 times 3, 8 times 11 is 88, then we multiply 88 by 3, that is 24, 8 times 3, we get 24, we carry 2. 8 times 3, that is still 24, plus 2, we get 26. So it simply means that 88 multiplied by 3 is 264 as the required answer. Uliniambia time imebakia na dakika ngapi? Zimeisha. So we have an exercise that is supposed to help us find out whether we've understood whatever we've been talking about or not. The first question we have is, we are supposed to identify if the statements that are here are true or false. So the first statement we have is 4 times 2 is equal to 3 times 4. We find that 4 times 3 is equal to 3 times 4. We find that 4 times 3 and 3 times 4 is just the same statement. We were talking about the commutative rule. And with the commutative rule, we said that the order doesn't matter. So it means this statement is true. And in this statement, whatever they have applied is the commutative rule. Then the second statement that we are having is 2 times 5 times 6 is equal to 6 times 5 times 2. So we find that in this statement, we are having 2 times 5 times 6. Then on the other side of the equation, we have 6 times 5 times 8. In this case, whatever they have decided, in the first case, they are starting with 2 times 5. In the second case, they are starting with 6 times 5. So the pair they have started with doesn't matter. The answer will definitely be the same. So what do I mean? It means that this statement is very true. And the rule that has been applied in this statement is simply the associative rule. So we are saying that this statement is true because they have applied the associative rule. Then the next statement we have is 11 times 5 is equal to 10 times 5. You discover that in this rule, they were trying to apply the distributive rule, whereby they were making the digit given to be a multiple of 10. Then after that, they were supposed to add or subtract a given number. So we find that the multiple of 10 we had is the number 10. Then with this 10, the mistake that was made, we were supposed to have 10 plus 1, then multiplied by 5. But in this case, there is no plus 1. So what does it mean? It means that this statement is false because there is a procedure that has been skipped in our statement. Then the other equation we have is 21 times 4 is equal to 2 times 42. In this equation, we find that whatever rule they are applying is that the doubling and the halving rule. So with the doubling, in this case, they have doubled 21 to 42. Then they have halved 4 to 2. So when you use the doubling and the halving rule, it means that our statement is very much true. So with this, the methods that we've used in our multiplication, you can find out in any case a statement that has been given by any given person, any student or any given individual in a given event, and find out, is the statement true, or is whatever that has been said true or false. So depending with the procedure that is being followed in multiplication of the numbers, then the answer that will be given will depend exactly on the procedure that has been given and the method that has been used. The method will simply result to the same answer, but the methods are applied in order to make the work easier in the multiplication processes, so that your multiplication is made easier in the process of calculating the sums that have been given out. So with that, we mark the end of the multiplication of small digits. We'll be looking at multiplication of large numbers in our next lesson.